Good evening, everybody, and welcome to Emerald Ticket. And uh, since the last session, we have finished our project, and as I promised, I'll be doing a revision of everything that we have learned because it's been a long, long journey, I guess. And to wrap everything up, it is very important for us to go through all that stuff that we have went through so that it becomes clear in our heads. So without wasting any time, so let's get started. As you can guess, yeah, I won't be writing any more code because we have done with that part. Okay, so let's get started. So let's start from the very beginning of what we have learned and what we have to haven't learned. As I always said, it is very important for you to understand all the concept, grasp all the concept, because the code is very volatile. Because scikit-learn is a very volatile library, and and as we know that it changes the location of the classes, and sometimes that creates errors like invalid class and all. Okay, and sometimes it removes the entire class. We have seen these things, but let's start from the full beginning and let's see. So, data visualization, part one. We said that the machine learning projects can be roughly divided into three main categories, that is data visualization, data pre-processing, and machine learning algorithms. We have went through all of this, so let's start with data visualization. um, So why data visualization is important? Imagine that you are in a market or you have to buy some veggies for your dinner. You pick up the best veggies just by looking at it. If it looks fresh, it is high probability that it is good. Okay, so you can just read through all the points that I have mentioned because we have done these things. So basically, data visualization is important to get a greater insight into the data. I am not from during this revision. I won't be talking in layman's term because we are done with that phase, and I can use terms that when I can use the terminology that is meant to be used, because these veggies and all these things are not is a not a efficient way to understand these things. So basically data visualization gives us the insight of the data set, and so that we can explore the new we can explore the correlation and all the other metrics, whether it is a tail heavy, whether it is a uh, bell curve, or the if the distribution is normalized or not. So all these things we could have a clear understanding if we do our data visualization. And to be honest, if you are working with a data set that you have never used before, then data visualization is the way to go. Conclusion from the histograms. If you remember our code. Let me get back to the code. Let me get back to the histograms. Yeah, this histogram, if you remember that all that we derived the first data visualization when we started out this data visualization, this histogram, and we made some conclusions from those. That is, the median income is not expressed in US dollars. Median income is caped. Housing median age and median income is also caped. Dealing with caped values, collect proper labels or remove the districts. Attributes have very different scales, tail heavy. Okay, so we have discussed that what is caped and what that whenever the data is scaled down or scaled at some point, the data becomes caped. And to be honest, this data are also known as pre-processed data. So we when we are working with machine learning project, we are doing machine learning projects and working with many data sets, you will come across data sets which will have pre-processed data. And to be honest, this is very very common. It is very rather it is very unique for you to get raw, extremely raw data set. Okay, because to be honest, it will be very big in size, and there will be a lot of things that you need to fix. Most of the times, all the famous datasets that you will be using, if you continue with this machine learning thing, beginner thing, then you will be using some of the very famous datasets like Titanic dataset. I'll be talking about a dataset for a while after a few minutes. So let's continue, and I'll be coming to back to that point. So we were discussing that whenever the data is scaled, it is also known as scaped data. And to be honest, this is very common for machine learning datasets to have pre-processed or caped data, and we don't need to worry much about these things. We only need to understand this thing that yes, there be aware of the thing that yes, the data which we have is caped. Okay, so some people may ask, I don't understand how it is caped and all. You just need to apply your common sense. Um, like here I mentioned this thing that that the graph housing median is the graph only extends up to 50 points, right? The 50 till the point of age of 50, it marks the data till the point if till the age of 50. So what happens after 50? So what happens when those people die or something, and they have to die in 50? There is no rule, right? So you have to make some common senses, and to be honest, you can look at the graph and you can very well understand the data is kept. And as you do more projects, you will have clarity on these things. And as you do things, as you continue with the visualization, you will gain more insight into the data. So let's just continue. So data pre-processing and why it is important. um, I gave you the examples that what if you bought your veggies and started eating them raw. It is not recommended, though it contains more nutrients, but it is not recommended. In the similar fashion, you should not be uh, মানে, inputting our model or giving our model raw data. It is very it is not recommended. But we have seen instance in our project that where I fed the raw data into the model. That if you can remember, I need to scroll way back down here. If oh, sorry. Yeah, if you remember this thing, the iris dataset that we used, we never did any kind of pre-processing, right? We never did any kind, we never visualized the dataset and all. We did nothing. We just fed the raw data uh, into our model. But to be honest, it you may say it turned out to be very good, right? Because to be honest, iris dataset is a very very famous dataset. Yeah, when we start learning. Uh, Classification problems. There are two evident data sets. Acha, I'll be talking about data sets a little bit while data. Let me just get to that point. So here you can see that we have not pre-processed the data or visualized the data. We just directly fed that thing into the model. So this thing is not recommended if you're not familiar with the data set that you're using. So what is the acha, problem with acha, before random sampling, let me just talk a little bit about this iris datasets and all the datasets in common. Basically, you get your datasets is from Kaggle. Okay, to be honest, that is a very famous website to get all your datasets. It contains all the famous datasets that even this dataset you can just search California housing dataset and you will come across this dataset that we are using right now. And another thing is um, when you are starting to learn, when you are learning things up, it is better to use the famous datasets that are being used for ages, like iris dataset, housing this dataset that we used in this project, that is the California housing dataset. There is eminist dataset, which contains the handwritten numbers. And if you guys still if you guys still want to, I can do a session on classification problem, addressing the classification problem, and then if we do that in the real future, we will be using a MNIST dataset. And this is to be honest, is a very fun dataset and fun to work with also. And there are multiple datasets like Titanic datasets. These are very useful and very famous datasets to learn machine learning. I won't suggest you to go directly for with the raw datasets. You can find raw datasets, of course, but if you directly go for the raw datasets, some of you may not understand all the pre-processing that needs to be done. And raw data is a little bit different from our processed data, so it is not recommended to go for raw data when you are learning things. Once you get the hold of it, you can pick up any data set and you can start applying these changes. So this is the thing. So we this session won't last very long, so let me just go through the things. So as you can see, I am not going through the code right now. I'll be going through the code in another session. To be honest, the code is not a problem. So yeah. So what is the problem with random sampling? If you remember that we had a problem with this train test split, and if you remember, if you go back to the sessions that we conducted, if you remember, if you you will remember, you will see me saying, Jay, this train test split will be explained later in the later. You will find the reason that why I'm not using this train test split later in the uh, sessions as we go on. Okay, so we can see the later at the end, very end, when we saw that cross validation thing and we split the data, and when we are checking the accuracy using the testing accuracy, and we split the data using train test split, we saw that whenever we are changing the random state, the accuracy is getting changed. So this is the very reason that I did not use train test split. But I would like to would like to say one thing. Jay, when you are doing your projects, go for this train test split. Okay, don't get it too complicated. Don't go for stratified and all. These things make a little bit more, it overcomplicates your project. Okay, so first things, if you overcomplicate your project at the very start or the beginning of the project, it becomes uh, difficult for you to go on with. So whenever you're trying for a machine learning project, just split the data using train test split. Don't go for stratified sampling. I just when I have shown you that thing because it is important for this data set. Okay, this is important. Stratified sampling is very important for this data set. Okay, but if you are using some other data sets, just go for train test split. It will work absolutely fine. We have seen, we have used train test split on our iris data set, and to be honest, it worked very fine, right? When it gave us, after all the fine tuning and all, we got a 98% accuracy. So but it also comes with its flaws, right? So testing test split is not as efficient as stratified sampling, but it's okay. So we are done right now with this thing. So what is the thing that needs to be done? There is the sampling techniques. There are two types of sampling techniques that we saw. That is stratified sampling and skewed sampling. I don't want to define those tools because you can find these definitions on the Google. And I think I have just copied this thing from the Google only. I don't remember everything. Okay, so let's move on. So next we address the problem of missing values, right? So let me see if we have missed. I think we have missed a lot of data visualization. To be honest, there is nothing much in these things. This is nothing much in these things, but still I want to explain this particular graph that we have. That this is the reason. If your dataset contains the longitude and latitude, please make use of it, because as you can see, this is the map of California, and you can very well understand from the color bar that is given, which actually represent the house values, that the all the houses near the sea or at the sea facing houses, or the sea facing houses are slightly more costly, it costs more, right? Okay, and the inland houses cost a little bit less. And you can also see that if you zoom into the data set, right? I don't want to zoom into because it will pixelate and the pixels will come out, but still, let's see if you can just zoom. Okay. Yeah, if you can see that we have small circles, so it can the circles determine the population. So we have a small population of very rich people owning this places, and if we can see the if we can see that we have large circles as we go inward, that is most of the people living in this area is middle class. That's what we want to say. Okay, so next we address the problem of missing value. We also have gone through this correlation matrix that we had. I think it is self-explanatory right now. I don't need to explain this thing one more time, because to be honest, this is very simple to understand once you get the heck of it. So next we went to missing values and all, and we saw the problem that may be caused if we have missing values in our data set. If we have missing value as data set, our there is a how do I say this? There is a void inside the knowledge that our model has right now. So we don't want that void, okay? Because these little voids will hamper our accuracy score very much. Okay, suppose you are not taking care of the missing values, and you are doing a model also getting a accuracy score of 95%. Okay, but if you do check on the missing values and give it some attention, give it some time, and fill out those missing values with some kind of value like median, mean, or anything that you want, you may see that the accuracy score jumps up to 98%. So 3% gain is a big deal, to be honest, when you are doing a machine learning projects. And yeah, so that's that. Then we divided. If you remember that we divided our data set into our training and testing data set, of course, and we then also detached the median column, so median rows value from our data set, because we don't want to apply any kind of pre-processing there. And to be honest, till whenever it is attached to the data set that we are working with, there is a high probability, though if we take even if we take care of it, there is a high probability that some some things may change. Okay, some things may change, and it may slip out, and you at the end, when you are checking the accuracy score, you won't be getting a good accuracy, and you will be scratching your head like what mistake that you have done. But um, you won't be able to find any, because that these basic mistakes cannot be detected, because this is a logical error, not a and not a compilation or runtime error. Okay, so yeah, so we saw some of the options that we can use to take care of these missing values. What is the solution to these missing values? That is, one first option is to delete the entire column. But when to use this? When the column contains over the 90% missing values. Okay, so if your column contains, if your as we have seen here, our dataset contains 20,640 data points. So if just imagine that in one of those columns, we have 10 columns, right? One of those columns contain about 20,000 null values, right? Or NaN values, right? So if that happens, then I would suggest you to delete that entire column, because it won't be useful in any way or the other. So the next thing that we have is to delete the entire row. So what if we delete that entire row, if we have missing values in any column, just delete that entire row. Okay, so when to use? When with the rows also contains missing values. Suppose a particular row contains out of the 10 rows, sorry, what I'm saying, right? Out of the 10 columns, if one particular row contains almost 8 missing values, right? Out of the 10 rows, out of the 10 columns, there are 8 missing values. So then it's a problem, and it is better to delete this thing. But most efficient way to do handle this particular problem, that is to fill out the missing values. That is most of the case that in most of the data set you will get, you won't be having too many missing values. It may have a few missing values here and there, but you need to fill them up. And as we say, as we have as I have written here, that when to use that when we have few missing values. Okay, don't apply this thing to a very large amount. Like if you have a column which 90% null, and you fill out those columns using the median values, it won't be doing good because you are overgeneralizing. At some point you will be overfitting the model from the very base of the model. Mane, not even machine learning, it is not even related to machine learning algorithms, but you are overgeneralizing, and to be honest, it will greatly overfit the data. And um, algorithms comes in a very later stage, but you are overfitting the data at the very base of the definition of a data set. So to be honest, this is a fairly the third process is the most common process that to use, to be honest. And you can use any kind of values to fill in the missing values, you to fill the void that the dataset has. So basically, you can choose anything. There is median, mode, mean, anything, any mathematical thing, or you can come up with some complex, very complex formula to get the missing values. It can be different for each one. You can do many types of things. To be honest, this is a very controversial and debatable topic, that what value to choose to fill out these missing values. To be honest, median is the most easy to do thing. Sorry, yeah, median, no, yeah, median. I guess, yeah, median. Okay, so you can just go for median. It will give you good accuracy, I would say. But you can try out with other values, and I would suggest you try out the other values so that you get a good understanding of what we are doing. Okay, you can read more on this online as you go, and please just check it out. It is a little bit. It's fun. I won't say it's not fun. So, okay, so we are going to stop here. I'm not going to burden you all with all the information that we have gathered, and we have done this everything in a very slowly, and we went through everything. We went through the code, and also I have written everything, and but I am just going through it again because we have learned so many things that sometimes it can be a little bit confusing for some people, and that's why I'm just revisiting every topic that we have learned. And we have completed I have just covered the 20-33% of the project, and rest we will continue from the next session. So I uh, you can sign off and enjoy the rest of your evening.